Hello students and welcome to the channel SNW Physics Classes. If you really understand the concepts taught here, please turn the black to blue. That means like the video, share with your friends and subscribe to the channel SNW Physics Classes. For the latest update, do not forget to hit the bell icon. This is the second part of the topic refraction of light. For the first part of the same topic, you can go through the link given in the description box. If you have any problem or any doubts related to the topic, you can comment in the comment section. So let's begin with the topic. Today we will discuss the topics. The topics to be discussed are spherical lenses, that is convex and concave lens, some terms related to spherical lenses, rules for obtaining images formed by spherical lenses, and the last we will discuss formation of images by spherical lenses. So the very first topic is, what is a lens? It is a piece of transparent glass bound by two spherical surface. ठीक है, ट्रांसपेरेंट ग्लास हम लोग ले लेते हैं और उसे दो साइड से जो है स्फेरिकल सरफेस दो तरह से बनाते हैं. लेट मी एक्सप्लेन यू विद द हेल्प ऑफ अ डायग्राम. लेट इट बी द स्फेरिकल बॉल. ठीक है, एक ग्लास का बना हुआ स्फेरिकल बॉल है और इस तरह से अगर हम लोग इसमें से दो सरफेसेस को ऐसे कट आउट कर लेते हैं, ठीक है, निकाल लेते हैं इसको इस तरह से, और फिर जब ये दोनों सरफेसेस को हम लोग आपस में अटैच कर देते हैं. ओके, कैन यू इमेजिन दिस टू सरफेसेस? इमेजिन कर सकते हैं यहाँ पे. तो दिस इज द दिस सरफेस, फर्स्ट सरफेस, एंड दिस वन, दिस साइड इज द सेकेंड सरफेस. ओके, सो इन सच अ सिचुएशन वी कैन मेक द लेंस. ये क्या होता है? एक ट्रांसपेरेंट ग्लास होता है जो दो साइड से, दो सरफेस से, दो स्फेरिकल सरफेस से आपस में ज्वाइंट होता है. लेंस आर ऑफ टू टाइप्स, कॉन्वेक्स लेंस एंड concave lens. Okay, what is convex lens? The lens which is thick at the center but thinner at the edges. ठीक है, जो सेंटर पे थिक हो और एजेस जो उसके किनारे होते हैं उस पे वो थिन हो, दैट इज कॉल्ड कॉन्वेक्स लेंस. यहां से हम लोग समझेंगे, यहाँ पे अगर इन दो पीस ऑफ ग्लास, इन दोनों को अगर हम लोग इस तरह से ज्वाइन करें, लेट इट बी द फर्स्ट पार्ट. ये फर्स्ट पार्ट है, इसको इस तरह से ज्वाइन किया एंड सेकेंड पार्ट को हम लोगों ने इस तरह से इन दोनों को आपस में ऐसे ज्वाइन कर लिया. देन वी गेट द कॉन्वेक्स लेंस. ओके, concave lens, a lens which is thin at the middle, means it is thin at the center but thicker at the edges. ठीक है, edges पे जो है ये thick है और center पे यानी middle में जो है ये thin है. इस तरह के लेंस को हम लोग कॉनकेव लेंस बोलते हैं. अब इसकी फॉर्मेशन कैसे होती है, लेट मी एक्सप्लेन यू. इट इज द फर्स्ट पार्ट. फर्स्ट पार्ट के को हम लोगों ने इस तरह से रखा और फिर सेकेंड पार्ट को हम लोग ऐसे इस साइड पे ला करके इसे ज्वाइन करा दिया. ओके, देन अ कॉनकेव लेंस इज formed. Now we will see some terms related to spherical lenses with the help of a diagram. So the very first term is principal axis. It is the perpendicular line, or we can say it is the imaginary perpendicular line drawn at the center of the lens. Okay, it is the center of lens, and principal axis is an imaginary perpendicular line which is drawn at the center of the lens. This is a convex lens, or we can say converging lens, because the ray, or we can see the parallel ray coming from the infinity, meets at one point after converging, and that point is known as focus. ठीक है, जो parallel rays इस लेंस से पास हो रही है, after being refracted, it meets at a point, and that point is known as focus, or we can say principal focus. Next term is optical center. It is the center of the lens. We can define optical center as the center of the lens is known as optical center. It is represented by capital O or capital C. Next term is focal length. The length between the optical center and the focus or principal focus is termed as focal length. Similarly, here we can say in the case of concave lens, it is known as diverging lens also. Concave lens को हम लोग diverging lens भी बोलते हैं because the ray parallel to the principal axis, जो ray principal axis के parallel होकर के आती है, after being refracted, it diverges or spread in different direction. ठीक है, रिफ्रैक्शन के बाद जो है रेज जो है वो स्प्रेड हो जाती है, डाइवर्ज करती है. सो दिस लेंस इज नोन एज डाइवर्जिंग लेंस. हियर आल्सो वी कैन से principal focus, optical center, principal axis, all the terms are same as the convex lens. Now let us define all the terms. What is optical center? The center point of a lens is known as optical center. Second term was principal axis, the line passing through the optical center of a lens and perpendicular to both the phases of the lens. ठीक है, जो line हम लोग draw करते हैं perpendicular to the center of the lens, it is passing both the phases of the lens. ठीक है, दोनों side जो है वो pass करती है. That's why I have written here both the phases of the lens, which is called principal axis. What is principal focus then? The point on the principal axis to which light rays parallel to the principal axis converges or appears to be diverging after refraction. ठीक है, यहाँ पे दो केसेस होते हैं. इन द केस ऑफ कॉन्वेक्स लेंस, द rays which is parallel to the principal axis converges or meets at a point, but in the case of concave lens, all the rays diverges or it appears to be meeting at a point, and that point is called principal focus of the length. Next term is focal length. The distance between the optical center and the principal focus is known as focal length. Now we will see rules for obtaining images formed by spherical lenses. We have three rules. Number one is the ray of light which is parallel to the principal axis of a spherical lens passes through its focus after refraction through the lens. Here we have both types of lenses. It is convex lens and this one is concave lens. So we will write all the terms here. It is optical center. It is F1. Let this side be also, it is F1. Now we will know different rules for obtaining images formed by spherical lenses. There are three rules. First rule says that a ray of light which is parallel to the principal axis of a spherical lens passes through its focus after refraction through the lens. What does it says? Let me write all the terms here. It is optical center. It is first focus, that is F1. It is twice the first focus, that is 2F1. This one is the second focus, F2. This is twice the second focus, that is 2F2. Now we will understand what does the first rule says. It says that a ray of light which is parallel to the principal axis, जब कोई ray principal axis के parallel होती है, then after being refracted is it is passing through the principal focus. First rule says that कि अगर कोई ray of light जो है principal axis के parallel है तो after refraction it will pass through the principal focus. ठीक है, same thing it will happen in concave lens. Let it be optical center first focus, that is f1. This is the twice first focus, that is 2f1. This one is second focus, that is f2. It is f2. This is twice the second focus, हम 2f2 लिख सकते हैं. Okay, same thing happens here when the ray of light parallel to the principal axis falls or incident on the lens, then after being refracted it passes through the principal focus. After being refracted it passes through the principal focus. As it is a diverging lens, so it will appear to be passing through the principal focus. ये एक diverging lens है, तो ये actually pass नहीं करेगा. It will appear to be passing through principal focus. Rule 2, that is, a ray of light passing through the optical center of a spherical lens goes straight after refraction through the lens. ठीक है, यहाँ पे it is very easy rule that when a ray of light passes through the optical center, then it is sent back in the same direction, or we can say it is sent back on the same path of the spherical lenses. Let me draw the path. If it is going or incident through this path, then it will return on the same path after being refracted. Now the rule 3 says that a ray of light passing through the focus or principal focus of a spherical lens becomes parallel to its principal axis after refraction through the lens. It is just like the rules we have learned in spherical mirror. ठीक है, जिस तरह से हम लोगों ने मिरर में पढ़ा था उसी तरह से ये तीनों रूल्स जो है वो एग्जैक्टली वही है, बट यहाँ पे हम लोग का चेंज क्या है, दैट इज वहां पे हम लोग मिरर के केस में पढ़े थे, यहाँ पे हम लोग लेंसेज के केस में पढ़ेंगे. वहां रिफ्लेक्शन था और यहाँ पे रिफ्रैक्शन था. अगर आप लोगों ने रिफ्लेक्शन ऑफ लाइट पे वीडियोस नहीं देखा है, देन यू कैन go through the link given in the description box. So the rule says that if a ray of light is passing through the principal focus, then after refraction it will go parallel to the principal axis. ठीक है, ये रूल क्या कहता है कि अगर कोई रे जो है principal focus पे इंसिडेंट की, then after being refracted it will go parallel to the principal axis. Similarly, in the case of concave lens, we can see here if a ray of light falls on the principal focus, then it will go parallel to the principal axis after being refracted. ठीक है, यहाँ पे भी हम लोगों ने देखा कि ray of light is falling on the principal focus, or it is appears to be falling on the principal focus. After being refracted, it will go parallel to the principal axis. So we have understood all the three rules. Now we will see how we can form images using spherical lenses. So the next topic is formation of different types of images by spherical lenses. In very first case, we will see how we can form images by placing the objects on different position of a spherical lens or a convex lens. So in convex lens, we have 6 cases. Let us see case 1. Image formed by a convex lens when the object is placed between optical center and principal focus. Here we have already kept one object between optical center and principal focus. So let us see how we can form image. The first rule says that when a ray of light goes parallel to the principal axis, then after being refracted, it will pass through the principal focus. जब ray of light जो है वो principal axis के parallel जाएगी, ठीक है, इंसिडेंट होगी, तो आफ्टर रिफ्रैक्शन इट विल पास थ्रू द फोकस. ठीक है, रिफ्रैक्शन के बाद जो है वो प्रिंसिपल फोकस से क्रॉस करेगी या पास करेगी. नेक्स्ट, द सेकेंड रूल सेज दैट व्हेन a ray of light passes through the optical center, then it is sent back in the same direction. It is sent back in the same direction. Here we can say these two rays, here we can easily see that these two rays are diverging, means they are going in different direction. So they will meet this side. So these rays will meet. Formation of different types of images by spherical lenses. At very first, we will see how we can form different images with the help of a convex lens. Here, in the case of convex lens, we have 6 cases. Let us see all the cases one by one. Case 1, that is image formed by a convex lens when the object is placed between optical center and focus. यहाँ पे हम लोगों ने ऑब्जेक्ट को ऑप्टिकल सेंटर और प्रिंसिपल फोकस के बीच में रखा है. Now let us see how we will form the image, how image is formed with the help of the rules we have already discussed. So the first rule says that when the ray parallel to the principal axis, okay, falls on the spherical lens, then after being refracted, it goes through the principal focus. Refraction के बाद जो है वो ray कहाँ जाएगी? It will pass through the principal focus. The ray is incident on the spherical lens, and after being refracted, it passes through the principal focus. Second rule says that when a ray of light passes through the optical center, okay, when a ray of light passes through the optical center, then it is sent back in the same direction. It is sent back in the same direction. Here we can see that these rays are not meeting each other. ये intersect नहीं करेंगे आगे भी जा करके. So they are intersecting this side, same side of the object. Object की side ही जो है ये आपस में intersect कर रही है. So we will meet these two lines for the formation of image. ठीक है, यहाँ पे ये दो rays जो है, what is image? The point where two or more than two rays meets is known as an image. So the image will be formed here on the same side of the object. On the same side of the object, we will get the image. Let it be B dash, as it was A, B. So it will be A dash. Now we will see the nature of image formed. That is, it is behind the object. Object की ये जो है image जो है वो object के पीछे बनी है. ओके, इट इज वर्चुअल एंड इरेक्ट लार्जर देन द ऑब्जेक्ट. वर्चुअल एंड इरेक्ट कहने का मतलब है इट इज सेम साइड ऑफ द ऑब्जेक्ट, और ये वर्चुअल है यानी ये सीधा है, एंड इट इज अबव द प्रिंसिपल एक्सिस. ठीक है, प्रिंसिपल एक्सिस के ऊपर बनी है. ओके, एंड इट इज लार्जर देन द ऑब्जेक्ट. ऑब्जेक्ट से इसकी हाइट जो है वो बड़ी है. सो द नेचर ऑफ इमेज इज इट इज बिहाइंड द ऑब्जेक्ट, वर्चुअल एंड इरेक्ट, एंड लार्जर देन द ऑब्जेक्ट. Case 2, for the image formation in convex lens. Case 2 says that when we put the object or we place the object at principal focus of a convex lens. We have already put an object here. यहाँ पे हम लोगों ने एक object रखा है, that is AB. AB एक object है जो कि किसी convex lens के principal focus पे रखी हुई है. Now we will form the image. यहाँ पे image formation देखेंगे. The first rule says that when a ray comes parallel to the principal axis and falls on the convex lens or any spherical lens, it goes or it passes through the principal focus after being refracted. After refraction, it will pass through the principal focus. It is the incident ray and it is the refracted ray. Okay. Second rule says that when a ray of light passes through the optical center, then it will be sent back in the same direction. यहाँ पे हमारा optical center है and the ray is passing through the optical center and it is again sent back on the same path. So here we get a parallel line. For the image formation here, we have to put screen. Okay, just like projector में हम लोग जो है वो screen वहाँ पे रखते हैं so that we can get the image. Okay, so to find out the image, to form the image here, we have to put one screen so that we can get the image. As the rays are parallel, they are not meeting. So the nature of image formed is it will be at infinity. Rays जो है वो infinity पे form हो रहे हैं. Next is it is real and inverted and it is highly enlarged. ये जो object है इससे बहुत ज़्यादा magnify होकर के हम लोगों को image मिलेगी. So the third case is when the object is between principal focus and twice the principal focus, means between f and 2f. ठीक है, जब हम लोग ऑब्जेक्ट को f और 2f के बीच में रखेंगे तो हमारा इमेज कैसे बनेगा. लेट अस सी. लेट इट बी a and this one be b. ठीक है. Okay, now again we will apply the first rule, that is when the ray coming parallel to the principal axis, it passes through the principal focus after refraction. Okay, second rule says that when a ray passes through the optical center, it will send back or it will come back along the same path. ठीक है, यहाँ पे हम लोगों ने दोनों रूल्स को अप्लाई कर लिया एंड वी गेट वन इंटरसेक्टिंग पॉइंट. ठीक है, यहाँ पे हम लोगों को एक इंटरसेक्टिंग पॉइंट मिला है एंड दैट पॉइंट वी विल गेट द इमेज. उसी पॉइंट पे हम लोगों को इमेज मिलेगी. ओके, हियर इज द इंटरसेक्टिंग पॉइंट. यहाँ पे हम लोगों को इंटरसेक्टिंग पॉइंट मिली है. सो वी विल गेट द इमेज हियर. This one is the image of the object. यहाँ पे जो object है उसकी image जो है हम लोगों को यहाँ पे मिली, that is B dash A dash. Let it be B dash and this one be A dash. Okay, now we will see the nature of image. It is beyond 2f. 2f 2 के पीछे में हमारा बना है ये image. it is real and inverted. How we can recognize it is real and inverted? Because it is below the principal axis. Principal axis के नीचे बनी है image, so it is real and inverted. And obviously we can see that it is larger than the object. ये object के height से जो है वो इसकी height जो है वो बड़ी है, so it is larger than the object. Now the fourth case is when the object is at 2f. ठीक है, twice the focus जो है हम लोगों ने 2f देखा, उस पे अब हम लोग ऑब्जेक्ट को प्लेस कर रहे हैं. ओके, लेट इट बी A and B. So according to first rule, a ray of light coming parallel to the principal axis will pass through the principal focus after refraction. पहला रूल हमारा ये कहता है कि जब कोई रे ऑफ लाइट जो है प्रिंसिपल एक्सिस के पैरेलल जाती है, then after refraction it will go through the principal focus. Second rule says that when a ray of light passes through the optical center, then after refraction it will pass along the same path. ठीक है, रिफ्रैक्शन के बाद जो है वो सेम पाथ को फॉलो करेगी and it will be sent back along the same path when a ray of light is incident on the optical center. When a ray of light is incident on the optical center, then it will pass along the same path after refraction. So the image formed is on 2f. हम लोगों को image कहाँ मिला? 2f पे मिला, but opposite side of the object. Object के सामने वाले जो 2f है, जो same distance पे है, उस 2f पे हम लोगों को object की image मिली. Now let us see what are the different nature of image formed. At distance 2f on the other side of the lens. Lens के दूसरी तरफ जो है 2f था, उस 2f पे हम लोगों को इस object की image मिली. Next, it is real and inverted. We can see it clearly that it is below the principal axis, so the image formed is real and inverted, and it is same size of the object. It is exactly the same size of the object. Object और image की जो size है, they are same. Case fifth is when we place the object beyond 2f. ठीक है, हम लोगों ने जब ऑब्जेक्ट को 2f के पीछे रखा, तब हम लोगों को कैसी इमेज मिलेगी? लेट अस सी. यहाँ पे मैं एक ऑब्जेक्ट यहाँ पे ड्रॉ कर देती हूँ फिर. ओके, फर्स्ट रूल, अकॉर्डिंग टू फर्स्ट रूल, it says that when a ray of light goes parallel to the principal axis, it passes through the principal focus after refraction. ठीक है, यहाँ पे जो ray of light है जो principal axis के parallel जाएगी, after refraction it will go on the principal focus or through the principal focus. In this case, we will again apply the second rule, that is when a ray of light passes through the optical center, it comes back in the same direction or along the same path. In this case, we will get the image between f and 2f on the other side of the lens. ठीक है, यहाँ पे जो हमें image मिलेगी, that will be between f and 2f on the other side of the lens. Let it be AB. So the image will be B dash and A dash. This is the incident ray, this one is refracted ray. So again we will make the direction of rays here. Okay. Nature of image formed will be between f and 2f on the other side of the lens, it will be real and inverted. As you can see that it is below the principal axis and its height will be smaller than the object. The sixth case is when the object is at infinity. मीन्स ये जो ऑब्जेक्ट है ये एक इनफाइनाइट डिस्टेंस पे है, तो इस केस में इमेज जो है वो कैसी बनेगी, लेट अस सी. द रेज आर कमिंग पैरेलल फ्रॉम इन्फिनिटी. ठीक है, ऑब्जेक्ट जो है वो बहुत दूर है, सो यहाँ पे हम लोगों ने ऑब्जेक्ट को कंसीडर नहीं किया है. द रेज आर कमिंग parallel to the principal axis from infinity, and according to the first rule it will pass through the principal focus. Again, at least two rays we need to form an image, so these two rays are coming from infinity and it will pass through the principal focus after refraction, so the image formed will be at principal focus. यहाँ पे इमेज जो है वो प्रिंसिपल फोकस पे ही फॉर्म करेगी. एट द principal focus the image is formed, and as it is very small, it is highly diminished, so we can see the point size image here. Okay, the nature of image will be at the focus, real and inverted, and it is much smaller than the object. As clearly we can see here, it is point sized object. Now let us sum up all the images formed by convex lens. So the first case was between f and optical center, means between principal focus and optical center. The position was of image was, that is, on the same side of the object, it was enlarged, and the nature was virtual and erect. It is the only case when we get virtual and erect image in the case of convex lens. Next case was at principal focus. The image formed was at infinity. It was highly enlarged and it is real and inverted. The third case was between principal focus and twice of principal focus, or we can say f and 2f. The image formed was beyond 2f. It was enlarged, real and inverted. The fourth case was at 2f. The image was formed exactly on 2f on the other side of the lens. It was of same side of the size of the object and it is real and inverted. Fifth case was when we place the object beyond 2f. The position of the image was between f and 2f on the other side of the lens and it was diminished, means smaller than the object, and its nature was real and inverted. Sixth and last case was at infinity. When we place the object at infinity, we get the image at principal focus. It is highly diminished, or we can say it was point sized image. The nature was real and inverted. How we can form images in concave lens? Here we have only two cases. Case 1 is when the object is placed anywhere between optical center and infinity in front of a concave lens. Here the first case says that when object is placed between infinity, infinite distance, and optical center. So we will apply the rules. That is, first rule, when the ray of light goes parallel to the principal axis, then what happen, it will pass through the principal focus. As it is concave lens, so it will not actually pass, it will appears to be passing through principal focus, so it will meet like this. On the principal focus, it will go like this. It is the dotted line we have represented with green color. यहाँ पे हम लोग डॉटेड लाइन को यहाँ पे ग्रीन कलर से रिप्रेजेंट कर रहे हैं. इफ यू विल ड्रॉ इन योर कॉपी, यू जस्ट ड्रॉ अ डॉटेड line and match the principal focus like this. Second rule says that when a ray of light passes through the optical center, when a ray of light passes through the optical center, then it will send back along the same path. Let me make the direction of rays. This is refracted ray. In the case of optical center, it will pass along the same path. Okay, the image formed will be very small, that is diminished. ठीक है, यहाँ पे जो image हम लोगों को मिला, it is very small. As we already know that concave lenses always make virtual and erect image, and it also makes diminished image. Object से वो हमेशा छोटे size में image बनाते हैं concave lenses. So here is the image, that is A dash, and this one is B dash. Nature of the image formed is between optical center and focus. ठीक है, फोकस और ऑप्टिकल सेंटर के बीच में हमारा जो है इमेज बनेगा. इट इज वर्चुअल एंड इरेक्ट एज इट इज above the principal axis, so it is virtual and erect, and it is very small, so it is diminished. Second case of concave lens is when the object is at infinity or infinite distance from the concave lens. यहाँ पे जो object है, it is at infinite distance. We don't know the distance of the object. In this case, we will get the image as, again we will follow the same rule. The rays are coming from infinity and it is diverging. ठीक है, as it is a diverging lens, so the rays will diverge in this case. So it is the incident ray. This one is a refracted ray. After being refracted, it passes through the principal focus as it is the case of concave lens. It will not actually pass, it will appears to be passing through principal focus. Okay, again it will go in this direction. ठीक है, all the rays are coming from infinity, तो ये क्या होगा, फिर से ये इस तरह से diverge करेगा और it will appears to be meeting at focus. We will again draw a dotted line to represent the appearance, or to represent that rays are meeting at principal focus. So the nature of image formed will be, the image will be formed on principal focus. It will be virtual and erect as it is the case of concave lens. The image will always form virtual and erect, that is above the principal axis, and it will be highly diminished. If you have any doubt, you can write on the comment section, or you can contact me via my email ID, which is given in the description box. Thank you very much for watching.